In the early hours of January 24th, 1961, when a B-52 Stratofortress bomber broke apart in the skies above eastern North Carolina, two Mark 39 hydrogen bombs separated from the aircraft and began falling toward the farmland surrounding the small community near Goldsboro. One of the bombs descended under a deployed parachute and completed much of its arming sequence before coming to rest intact in a field. But the second weapon followed a very different trajectory. Without the parachute deployment that slowed the first bomb's descent, the second weapon fell rapidly and struck the ground with tremendous force in a waterlogged agricultural field several miles from the crash site. The impact drove much of the bomb deep into the soft soil, scattering debris across the surrounding farmland, while burying critical components of the weapon beneath layers of mud and groundwater. In the immediate aftermath of the crash, the United States Air Force launched an extensive recovery operation to locate and retrieve every piece of the two nuclear weapons involved in the accident. Teams of specialists from nuclear weapons laboratories, the Air Force, and the Atomic Energy Commission were dispatched to the site to conduct a systematic search for the scattered components. Their objective was clear: locate all parts of the bombs, secure the nuclear materials, and ensure that nothing remained in the environment that could pose a hazard or reveal classified design information about the weapons themselves. The recovery operation began within hours of the crash and quickly transformed the quiet farmland surrounding the impact site into a heavily guarded military zone. Roads leading into the area were blocked by military vehicles, while soldiers established a perimeter around the fields where debris from the bombs had been found. Specialized teams equipped with radiation detectors and excavation equipment began combing through the muddy soil in search of the weapon's components. The Mark 39 hydrogen bomb was a complex thermonuclear device composed of multiple stages and subsystems, including the primary fission stage, the secondary fusion stage, electrical arming systems, high explosive lenses, and structural components designed to hold the weapon together during delivery by aircraft. When the second bomb struck the ground without its parachute, the force of the impact caused the weapon to break apart, driving some components deep into the saturated farmland while leaving others scattered across the surface. Investigators quickly located several large pieces of the weapon, including sections of the bomb casing and parts of the non-nuclear components. However, as the excavation continued, it became clear that the primary stage of the bomb, the portion containing the nuclear core and associated firing mechanisms, had penetrated far deeper into the ground than expected. The farmland where the bomb had landed was characterized by soft, waterlogged soil that had been saturated by winter rains. When the heavy weapon struck the ground at high speed, the soil offered little resistance, allowing the bomb to plunge deep beneath the surface. Initial excavation efforts recovered some parts of the weapon from relatively shallow depths, but the most critical components remained buried far below the reach of ordinary digging equipment. As the recovery teams continued their work, engineers attempted to determine exactly how deep the primary stage of the weapon had been driven into the earth. Estimates suggested that the component might have penetrated more than 50 feet below the surface, possibly reaching layers of waterlogged clay that made excavation extremely difficult. Each attempt to dig deeper caused groundwater to flood the excavation pit, turning the soil into thick mud that collapsed back into the hole as soon as workers tried to remove it. Pumps were brought in to remove the accumulating water, but the volume of groundwater seeping into the excavation made progress slow and hazardous. The deeper the teams dug, the more unstable the surrounding soil became. Despite these challenges, The recovery operation continued for several days as engineers debated whether it was possible to reach the remaining components of the bomb. Nuclear weapons specialists were particularly concerned about the primary stage, which contained highly sensitive materials associated with the weapon's nuclear design. Recovering the component would ensure that no classified technology remained buried in the field. However, the conditions at the site made further excavation increasingly impractical. The combination of unstable soil, groundwater flooding, and the unknown depth of the buried component created a situation where deeper digging could potentially collapse the entire excavation area. Eventually, the recovery teams reached a point where continuing the excavation would require heavy equipment capable of removing massive volumes of soil while stabilizing the surrounding ground. Engineers calculated that such an operation would involve digging a much larger pit around the suspected location of the buried component, potentially extending across a significant portion of the farmland. Even then, there was no guarantee that the primary stage could be recovered if it had penetrated deeply into the underlying clay layers. At the same time, investigators had already recovered enough components from the bomb to confirm that the weapon's nuclear detonation sequence had not been triggered. The nuclear core had not exploded, and the safety mechanisms built into the Mark 39 had prevented the catastrophic detonation that might otherwise have occurred. Faced with these conditions, Air Force officials made a decision that would remain largely unknown to the public for decades. Rather than continue digging indefinitely in an increasingly unstable excavation, the recovery operation would be halted once all accessible components had been retrieved. The remaining portion of the bomb, the deeply buried primary stage, would be left in place beneath the farmland. To ensure that the buried component remained undisturbed, the Air Force arranged to purchase a permanent easement on the property where the bomb had impacted. The easement granted the government control over a small section of the land, allowing officials to restrict excavation in that area without revealing the true reason to the landowner. The arrangement was handled quietly. The property owner was informed that the government required an easement for safety reasons related to the aircraft crash that had occurred on the land. No detailed explanation was provided about what remained buried beneath the field. From the perspective of the Air Force, leaving the component in place posed little risk as long as the area remained undisturbed. The nuclear materials inside the primary stage were sealed within protective casings designed to withstand harsh conditions, and without the precise sequence of arming signals required for detonation, the device could not produce a nuclear explosion. The buried component would simply remain deep underground, isolated from the surrounding environment. Over time, the farmland returned to its normal appearance. Crops were planted in the fields surrounding the restricted area, and the crash site gradually faded into local memory. Yet beneath that quiet field in eastern North Carolina, part of a thermonuclear weapon remained buried where it had been driven into the earth during the B-52 breakup in 1961. The Air Force retained its easement on the land, quietly maintaining control over the small section of property where excavation was prohibited. For decades, the existence of the buried component remained largely unknown outside a small circle of officials and nuclear weapons specialists who had been involved in the original recovery operation. The story of the buried bomb component would eventually raise broader questions about the hidden legacy of nuclear weapons accidents across the United States during the Cold War. The recovery teams working the Goldsboro crash site in January 1961 understood that the conditions beneath the farmland were unlike those faced in most aircraft accident investigations. The B-52 breakup had scattered debris across several miles of rural Wayne County, but the impact point of the second, Mark 39 hydrogen bomb, presented an unusually complex problem. When the weapon struck the saturated soil at high speed, it did not simply break apart on the surface. The bomb's heavy internal components behaved almost like a projectile penetrating soft earth, driving downward through layers of wet topsoil and clay. Early excavation revealed fragments of the bomb casing, electrical wiring, and sections of non-nuclear equipment embedded at various depths beneath the field. Each recovered piece helped investigators reconstruct the path the weapon had taken as it buried itself. But the deeper the recovery teams dug, the more unstable the excavation became. Water from surrounding farmland seeped into the pit continuously, turning the soil into thick mud that collapsed inward as soon as digging equipment attempted to expand the hole. Engineers from Sandia National Laboratories and the Atomic Energy Commission were among the specialists brought to the site to advise the Air Force on how to proceed. Their primary concern was the recovery of the bomb's primary stage, which contained the fission component used to trigger the thermonuclear reaction in the weapon's secondary stage. Although the bomb had not detonated, the primary stage still contained sensitive materials and classified design features. Leaving such components buried in an uncontrolled environment was not an outcome the recovery teams preferred. Yet the technical challenges associated with extracting the component quickly became apparent. The farmland in eastern North Carolina consisted of waterlogged soil resting atop dense clay layers. When the bomb penetrated the ground, it likely passed through the upper layers and came to rest deep within the clay. Excavating down to that depth required removing massive volumes of unstable soil while preventing the pit from collapsing. Initial attempts to deepen the excavation pit demonstrated how difficult the task would become. Workers using bulldozers and digging equipment quickly reached depths where the surrounding soil began sliding back into the pit. Pumps were brought in to remove groundwater, but the water table in the region was high, and the excavation filled almost as quickly as it could be drained. Each additional foot of depth increased the volume of water entering the hole, while reducing the stability of the surrounding ground. Engineers realized that continuing to dig downward in a narrow shaft would likely cause the walls to collapse, potentially burying equipment and personnel inside the excavation. To prevent such a collapse, a much larger excavation area would be required. Instead of digging straight down to the buried component, the entire surrounding field would need to be opened into a wide pit that gradually sloped downward toward the suspected location of the bomb's primary stage. This approach would allow the sides of the excavation to remain stable, but it would also require removing enormous quantities of soil from the farmland. Investigators estimated that the excavation could expand across several acres before reaching the depth necessary to locate the buried component. Such an operation would require heavy machinery, extended construction work, and careful stabilization of the surrounding terrain. At the same time, engineers had to consider whether the primary stage had actually survived the impact intact. When the bomb struck the ground, enormous forces had been applied to its internal components. It was possible that the primary stage had been crushed or damaged as it penetrated the earth, potentially scattering smaller pieces deeper into the soil. If that had occurred, locating every fragment might prove impossible, even with a large excavation. The recovery teams therefore faced a situation where expanding the dig might not guarantee success. After several days of evaluation, Air Force commanders and nuclear weapons specialists reached a practical conclusion. The recovery operation had already retrieved most of the accessible components of the weapon. Investigators had confirmed that the bomb's nuclear detonation sequence had not been triggered, and that the weapon's safety systems had functioned as intended. Continuing the excavation to recover the deeply buried primary stage would require a major engineering operation with uncertain results. Under those circumstances, officials decided that the remaining component would be left underground rather than risking a large-scale excavation that could endanger workers and disrupt the surrounding farmland. The decision to halt the excavation did not mean that the buried component would simply be abandoned without precaution. Instead, the Air Force implemented a long-term control measure to ensure that the location remained undisturbed. Government representatives negotiated with the landowner to purchase a permanent easement on the portion of the property where the bomb had impacted. An easement is a legal agreement that grants the government certain rights over private land without transferring ownership of the property itself. In this case, the agreement allowed the Air Force to restrict digging or construction within a defined area of the field, while the landowner continued using the surrounding farmland for agriculture. The exact nature of the buried object was not fully explained to the landowner. Officials described the restriction in general terms, stating that it was necessary for safety reasons related to the aircraft crash and the recovery operation that followed. The Hasagitsi agreement ensured that the area would remain undisturbed indefinitely, while avoiding public attention that might arise if the presence of a buried nuclear weapon component were widely known. The restricted zone was marked quietly in government records, and the Air Force retained authority over the site. Once the easement had been secured and the excavation pit stabilized, the recovery teams gradually withdrew from the field. The site was backfilled, and the farmland was restored as closely as possible to its original condition. Within a short time, crops once again grew in the surrounding fields, and the physical traces of the recovery operation disappeared from the landscape. Yet beneath that quiet patch of farmland remained a portion of the Mark 39 hydrogen bomb that had fallen from the disintegrating B-52. For years afterward, the existence of the buried component remained known only to officials involved in the investigation and to specialists within the nuclear weapons program who maintained classified records of the incident. The Air Force continued to hold the easement on the property, ensuring that the buried section of the bomb would not be disturbed by future construction or excavation. Local residents living near the site were aware that a bomber had crashed nearby in 1961, but few understood that part of one of its nuclear weapons remained underground. The quiet management of the Goldsboro crash site reflected a broader pattern that characterized many Cold War nuclear incidents. During the decades when the United States maintained large numbers of nuclear weapons on constant alert, accidents occasionally occurred involving aircraft, missiles, or storage facilities. In most cases, the government conducted recovery operations quickly and classified the details of what had happened. Only years later, as documents were gradually declassified, did historians begin to understand how many such incidents had taken place and how they were handled. The buried component at Goldsboro therefore represents more than a single accident. It illustrates how the infrastructure of the nuclear age sometimes left physical traces embedded in the landscape, traces that remained hidden beneath fields, forests, and deserts long after the events that placed them there had faded from public memory. For decades after the Goldsboro crash, the quiet arrangement surrounding the buried component remained largely invisible to the public. The farmland above the impact site returned to normal agricultural use, and the easement held by the U.S. Air Force existed primarily as a line in government property records rather than a visible feature on the ground. Crops were planted and harvested in the surrounding fields, and the small, restricted patch where excavation was prohibited became simply another unusual boundary within the property. Yet beneath the surface, the remains of the Mark 39 bomb's primary stage still rested deep within the waterlogged soil, where it had been driven during the crash. The government's decision to leave the component in place reflected a calculation that recovery would be more dangerous and costly than allowing the object to remain buried indefinitely. The nuclear materials within the primary stage were sealed within protective casings designed to contain them under a wide range of conditions, and without the precise sequence of electrical signals required to arm the weapon, the device could not produce a nuclear explosion. From a technical standpoint, the buried component represented a stable but permanently lost artifact of the accident. As the decades passed, however, historians and researchers examining Cold War nuclear incidents began uncovering details about the Goldsboro recovery operation through declassified documents and investigative reporting. These records confirmed that the Air Force had indeed halted excavation efforts after determining that the primary stage of the bomb had penetrated too deeply into the saturated farmland to recover safely. The documents also revealed the existence of the easement purchased by the government to prevent future digging at the site. For many observers, the discovery that a component of a thermonuclear weapon remained buried beneath private farmland raised broader questions about how many similar remnants of Cold War nuclear operations might still exist across the United States. The Goldsboro incident was not the only accident in which nuclear weapons or components were lost or left unrecovered. During the Cold War, the United States conducted thousands of flights involving aircraft carrying nuclear weapons as part of its strategic deterrence posture. Bombers routinely flew training missions across North America and over the Atlantic and Pacific Oceans, sometimes carrying fully assembled weapons and sometimes carrying partially configured devices used for training. Although strict procedures governed the handling of these weapons, the scale of operations meant that accidents occasionally occurred. Aircraft crashes, mid-air collisions, and mechanical failures sometimes forced crews to jettison weapons or resulted in weapons being lost in remote areas. Military terminology eventually classified such incidents under the category known as broken arrow, referring to accidents involving nuclear weapons that did not create a risk of nuclear war, but nevertheless involved the loss, damage, or accidental release of nuclear devices. In most broken arrow events, recovery teams were able to locate and retrieve the weapons involved. However, several incidents resulted in weapons or components that were never fully recovered. The hydrogen bomb dropped near Tybee Island, Georgia, in 1958 remained lost beneath the waters of Wassaw Sound after an unsuccessful search effort. In another case, nuclear weapons were temporarily lost in the ocean after aircraft accidents before later recovery operations succeeded in retrieving them. What made the Goldsboro incident unusual was the location of the buried component. Instead of resting in deep ocean water or remote wilderness, the primary stage of the bomb lay beneath farmland in a populated region of the eastern United States. The decision to leave the component underground effectively integrated a piece of nuclear weapons history into the everyday landscape of rural North Carolina. Farmers working nearby fields were largely unaware that a portion of a thermonuclear weapon remained buried just beneath the soil. The existence of such remnants has occasionally raised questions about long-term environmental and safety considerations. Nuclear weapon components contain materials that must remain sealed to prevent contamination of the surrounding environment. In the case of the Goldsboro primary stage, officials concluded that the casing surrounding the nuclear materials would remain stable underground, and that groundwater conditions would not compromise the containment system. The design of nuclear weapon components included protective barriers intended to prevent the release of radioactive material, even if the weapon experienced severe mechanical stress. Nevertheless, the knowledge that such materials remained buried beneath farmland prompted periodic interest from researchers who sought to understand the long-term fate of the component. At the same time, the Air Force continued to maintain the easement controlling access to the specific area of land where the bomb's primary stage was believed to be buried. The easement allowed the government to prohibit excavation or construction in that location, ensuring that the component would remain undisturbed. Although the land itself remained privately owned, the restricted zone functioned as a quiet safeguard protecting the buried object from accidental discovery. Over the years, the arrangement became one of the more unusual examples of how Cold War nuclear infrastructure sometimes intersected with civilian property and everyday landscapes. The broader significance of the Goldsboro site lies in what it reveals about the scale and complexity of nuclear weapons management during the Cold War. At the height of the strategic competition between the United States and the Soviet Union, thousands of nuclear weapons were deployed across a vast network of aircraft bases, missile silos, storage depots, and naval vessels. Maintaining this arsenal required continuous training, transportation, and technical operations involving personnel spread across the country. In such a vast system, accidents were rare relative to the number of operations conducted, but when they did occur, they often left behind physical traces that remained hidden for decades. The buried component of the Mark 39 bomb near Goldsboro therefore represents a quiet reminder of that era. Beneath a field that appears no different from the surrounding farmland lies part of a thermonuclear weapon that once fell from a disintegrating bomber in the winter of 1961. The recovery teams who worked the crash site retrieved most of the weapon and secured the nuclear materials that could be reached. Yet one portion proved too deeply buried in the unstable soil to recover, and so it was left in place while the government quietly secured control over the land above it. Today, the site remains largely unchanged, its existence recorded in property agreements and historical reports rather than visible markers on the ground. The farmland continues to produce crops, the surrounding countryside remains peaceful, and the events that placed the buried component there have long passed into history. Yet the story of that buried weapon continues to prompt reflection on how the machinery of the nuclear age once extended into unexpected corners of the American landscape. In the years since the Goldsboro accident, the field in eastern North Carolina, where the second Mark 39 bomb struck the ground, has remained outwardly ordinary. The land continues to be used for agriculture, and aside from the legal easement that restricts excavation within a small portion of the property, little distinguishes the site from the surrounding farmland. Yet the existence of a buried nuclear weapon component beneath that field has gradually become one of the most widely discussed examples of how Cold War nuclear operations left lasting traces across the United States. As government documents related to the accident were gradually declassified in later decades, historians and investigative journalists began examining the details of the recovery effort and the decision to leave the bomb's primary stage underground. These records confirmed that the Air Force had determined that further excavation posed unacceptable risks given the unstable soil conditions and the depth at which the component had likely come to rest. The official reports concluded that the nuclear materials within the primary stage remained sealed inside protective casings, and that the buried component presented no danger as long as the site remained undisturbed. The quiet management of the site illustrates a broader reality of Cold War nuclear infrastructure. The weapons themselves were only one part of a much larger system that included aircraft, missile bases, training ranges, maintenance facilities, transportation networks, and emergency recovery procedures. At the height of the Cold War, Strategic Air Command maintained continuous operations involving bombers armed with nuclear weapons, many of which flew training missions across the United States. These flights ensured that crews remained proficient in navigation, weapons handling, and long-distance strike procedures. The scale of these operations was enormous. Thousands of flights were conducted over the course of decades, and although safety procedures were designed to minimize risk, accidents occasionally occurred. When they did, recovery teams moved quickly to secure the weapons involved and contain any potential hazards. In most cases, the weapons were recovered successfully. In rare situations such as the Goldsboro crash, however, environmental conditions made complete recovery impossible. The buried component at Goldsboro is therefore not simply the remnant of a single accident, but also a reflection of how the strategic systems of the Cold War operated across the American landscape. The nuclear deterrent required an enormous logistical framework involving people, equipment, and infrastructure spread across the country. Aircraft bases hosted bombers capable of delivering thermonuclear weapons across intercontinental distances. Missile silos housed intercontinental ballistic missiles ready to launch within minutes. Naval vessels carried nuclear weapons beneath the oceans. Training exercises simulated the conditions of nuclear war to ensure that crews and commanders could respond if conflict ever occurred. Each of these systems involved complex machinery and technical procedures, and while they were designed with safety in mind, they were not immune to failure. Over time, the accumulation of historical research into Cold War accidents has revealed a pattern in how such events were managed. When a nuclear weapon was involved in an accident, specialized teams from the military and national laboratories were dispatched immediately to secure the site. Their responsibilities included locating the weapon, recovering nuclear materials, and preventing unauthorized access to classified components. If necessary, the government would establish control over the surrounding land, or water, to ensure that recovery operations could proceed safely. Once the immediate crisis had passed, the details of the incident were typically classified. Official reports were restricted to internal distribution, and public explanations often provided only limited information about what had occurred. The Goldsboro crash followed this pattern closely. Recovery teams arrived quickly, secured the area, and retrieved as many components of the bombs as possible. Once investigators determined that the weapons had not detonated and that the remaining component was buried too deeply to recover safely, the government implemented the easement arrangement to control the site. The decision to keep the details classified ensured that the presence of the buried component remained largely unknown for many years. As declassification efforts gradually released documents related to Cold War nuclear operations, the story of the Goldsboro field became more widely known. Reports describing the recovery effort and the buried primary stage attracted public attention because they revealed how close the United States had come to a nuclear disaster in 1961. The same accident that left a portion of the bomb buried beneath farmland also involved another weapon that had nearly completed its arming sequence while descending under a parachute. The combination of these events underscored the narrow margin that sometimes separated routine military operations from catastrophic outcomes. The Goldsboro site therefore occupies a distinctive place in the history of the nuclear age. It represents a location where a thermonuclear weapon once fell from the sky, and where part of that weapon remains buried more than 60 years later. Unlike missile silos or former military bases, the site does not contain visible infrastructure or monuments marking its significance. Instead, its importance exists primarily in historical records and in the legal easement that continues to restrict excavation in the small section of land above the buried component. For historians studying the Cold War, the field near Goldsboro provides a reminder that the nuclear arsenal was not confined to distant test ranges or remote military installations. The systems designed to manage and deploy nuclear weapons were integrated into the everyday geography of the United States. Bombers flew over farmland and cities during training missions. Missile bases operated near rural communities. Nuclear materials were transported across highways and rail networks. In that context, the buried component beneath the North Carolina field represents a fragment of a much larger system that once defined the strategic balance between two superpowers. Today, the farmland remains quiet, and the events of January 1961 have long passed into history. The legal easement remains in effect, ensuring that the ground above the buried component will not be disturbed. Beneath the soil, the remains of the Mark 39 bomb's primary stage continue to lie where they came to rest after the B-52 breakup. The component has remained sealed within the earth for decades, an artifact of the Cold War that was never fully recovered, and a reminder of how the nuclear age sometimes left traces in places where few people would expect them to be found.